guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be talking about partial pressures. So when we say partial, we're actually talking about the part of something. And when you add all of the partial pressures that we're going to calculate later, they should add up to the total pressure inside that sample. Okay? So for this problem, it states that a sample of a smokestack emission was collected into a 1.25-liter tank at 752 millimeter mercury and analyzed. The analysis showed 92% carbon dioxide, 3.6% nitrogen oxide, 1.2% sulfur dioxide, and 4.1% water by mass. What is the partial pressure exerted by each gas? So the formula for partial pressure is actually given by partial pressure is equal to the total pressure times the mole fraction of each component in the sample. Okay, so here we can identify one part of this equation, and that is the total pressure. We know that the total pressure is equal to 752 millimeter mercury. Okay, so the next step that we have to do to find the partial pressure is to find the mole fraction of each component in the sample. So mole fraction is actually the number of moles of the component. When we say component, we say one of these, either carbon dioxide, nitrogen oxide, sulfur dioxide, or water. And then all of that is divided by the total number of moles in the sample. So it's total number of moles. And how do you find the total? You just add the individual number of moles of each component. Okay. The next step is to equate. You have to equate each percentage to 1 gram. When we say equate each percentage to 1 gram, we say that the 92% carbon dioxide is actually equivalent to 92 grams of carbon dioxide in that sample. And 3.6% nitrogen oxide will be 3.6 grams. So the next step here is to find and list down the mass of each component. So the mass. So we have 92 grams of carbon dioxide, 3.6 grams nitrogen oxide, and then we have 1.2 grams of sulfur dioxide and 4.1 grams of water. And then what is the molar weight of each component? Kasi we know that from this triangle, the mass divided by the molar weight will give you the number of moles, right? So if you're going to find the number of moles of each component here, we have to divide all of these by their respective molar weight, which is for carbon dioxide, molar weight ng carbon dioxide is 12 plus 16 times 2, kasi yung oxygen is 16 grams per mole, and that is, adding up, we have 44 grams per mole. And then for nitrogen oxide, we have for nitrogen, we have 14 plus 16, so that is 30. Okay, and the molar weight of sulfur dioxide is, for sulfur, we have 32 plus 16 times 2, that is 64. We have 64 grams per mole. And then for water, we have 1 times 2. Say for hydrogen, it's 1 grams per mole. Plus oxygen, which is 16, we have 18 grams per mole. And then getting the number of moles, we have for CO2, we have to divide the mass by the molar weight. So we divide 92 by 44. So for CO2, we have 92 grams CO2 divided by 44 grams per mole. So ang unit natin here would be moles kasi makakancel yung grams and yung moles, buta siya sa taas. Okay? So ang number of moles of carbon dioxide in the sample is 92 divided by 44. That is 2.0909090901. Grams, moles, sorry, of carbon dioxide. And for nitrogen oxide, we have 3.6 grams divided by the molar weight, which is 30 grams per mole. And again, makakancel yung grams and matitira yung moles, which will be put in front. Okay. So 3.6 divided by 30, we have 0.12 moles of NO. And then next, we have for sulfur dioxide. The weight of sulfur dioxide is 1.2 grams of sulfur dioxide divided by the molar weight, which is 64 grams per mole. And again, makakancel yung units na gram and matitira yung mole. 1.2 divided by 64, we have 0.018 moles sulfur dioxide. And finally, for water, we have 4.1 grams of water divided by the molar weight of 18 grams per mole. Here, makakancel yung grams and mole. And the number of moles of water is 0.77778 moles of water. I just rounded it off kasi ang daming 7. So, ayan. Now, we gotta find the total number of moles. So, the total number of moles is equal to yung mole ng ng this one, carbon dioxide, NO, SO2, and H2O. So, ang number of moles ng CO2 plus number of moles of NO plus the number of moles of SO2 plus the number of moles of water. And how much is that? We have 2.09090991 plus 0.12 plus 0.0187 plus 0.2277778. So we have 2.45747436891 moles total. So that yun yung total number of moles. And now we're gonna get the mole fraction. So the mole fraction, we just have to divide everything here, carbon dioxide, nitrogen oxide, sulfur dioxide, and water by the total number of moles. Okay? So for carbon dioxide, ang mole fraction natin is NCO2 over NP, which is equals to 2.090909091 mole divided by total, which is 2.45. 7436891 mole. And from here, makikita natin na maka-cancel yung mole at yung mole fraction natin ay unitless. So 2 here, 1, we have 0.85. Zero 0.85, 0.8, 496. And round off lang siya. Okay, that's our mole fraction for CO2. And then for NO, ang mole fraction natin ay number of moles of NO divided by the number of moles. So ang mole fraction natin for NO is 0.12 divided by the total, which is 2.457436891. 74. And from here, maka-cancel ulit yung moles, and our mole fraction is unitless. Ang answer for here is 0.04. 0.04 8831 88314. Yeah. And then for SO2, it is number of moles of SO2 divided by the total. And that is 0.01875 divided by the total, which is 2.45 again. And calculating, we have we have 0.0076299. Yeah. And then finally for water, we have the number of moles of water divided by the total. And the number of moles of water natin ay 0.22778. So 2.22777 7777 89 divided by the total again. And calculating, we have 0.092689. Okay, so now finally we're gonna get the partial pressure. And if you want to add all of these mole fraction here, they should actually add up to 1 or close to 1. So the sum of all mole fraction should be equal to 1. And now we just have to calculate for the partial pressure of each component. So partial pressure now is equals to the total pressure times yung mole fraction natin of the component. And these are the mole fractions that we have found earlier. This one, this one, this one, and this. So we just calculate for the partial pressure now. So partial pressure of carbon dioxide is equal to the total pressure, which is 752 millimeter mercury times the mole fraction natin that we have found earlier, which is equal to 0.8508496. 0.8508496. Calculate later. And then now for nitrogen oxide, we have 752 millimeter mercury multiplied by the mole fraction, which is 0.048 here, 0.0488314. And the partial pressure of sulfur dioxide is equal to 752 times yung mole fraction niya, which is 0.076299. And then finally, the partial pressure of water is equals to 752 millimeter mercury times yung mole fraction niya, which is 0.092689. And calculating all of these, we have 6. For carbon dioxide, we have 639 point 839 millimeter mercury. Ito din yung units natin for the pressure. Kasi this one is unitless, di ba? So, mariretain lang tong units here. And for nitrogen oxide, we have 36.721 millimeter mercury. And then for sulfur dioxide, we have 5.738 millimeter mercury. And finally, for water, we have 69.702 millimeter mercury. And if you really want to check if your answer is correct, all of these should add up to the total pressure inside the sample. So 639.839 plus 36.721 plus 5.738 plus 69.702. We have 752 millimeter mercury, and this is the total pressure. So that is the solution for the problem. I hope you learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.